Ready?
Ready.
Ready. All right. I don't think me and you have prepared enough to deal with what's going on in the AI world. Think so? I don't think I'm ready. Yeah, I don't think even with all the preparation, I'm not ready still.
No, I think we're never ready. Yeah.
Yep, it's live. So let's talk about where we're going. What is happening in the world of AI in your world?
How's it going, Asif? Doing good. Man, the world of AI and semiconductor is always exciting. The change is just so rapid.
Yeah.
I mean, we've just watched, NVIDIA come out with a new Blackwell chip, and the evolution of AI and how fast it's changing so fast. That comes up with that kind of brings up a point of how does industry invest and how do you invest in the Blackwell chip right now? It's millions of dollars to invest in this, but that it's going to be outdated in the next 6 to 12 months. Like, how do you invest in something that is going to be with the rapid advancement? How do you invest in something as a corporation, knowing that this AI is going to be so rapidly evolving that you're not going to be able to? There's going to be a greater, better something just right around the corner, and knowing that your investment is not going to be good and that something else is going to take over. It's going to be interesting seeing this evolution and this rapid change of technology that that we're seeing right now going on.
Well, the managing the expectation about AI, right? I was like you called yourself the semiconductor chips industry evangelist. I was trying to evangelize the idea that you really have to manage your expectation about AI. And at one point, it turned blurry. I'm just like, is this a dream or is this really happening? The way things are coming out of all these labs, the papers that I've read, I've read, it's like, are they serious? Like, this is what they're going with this? So I think what I'm trying to say is I'm losing my ways of who I used to be and preach about, right? The idea that you really have to manage your expectation about AI. It's not going to be crazy bad or crazy good or crazy something else. At this point, I really feel like this is crazy, like impressively crazy.
Yeah, people always say, they're like, so what is it going to be like? I'm like, it's going to be good. It's going to be bad. It's going to be it's going to be good. It's going to be bad. It's going to be everything, right? And so, like, it's going to be an interesting world that we're going to live in. But
LinkedIn had a great post. Somebody said, I don't know who said it, but he said 2030 will make 2024 look like 1800s. It will. And I said, if you're onto something in the next 6 years, I want to be part of that. I'm really excited to see how the world changes. And one thing I will definitely put out, look, I'm a hardware guy. I love hardwares. I love semiconductor chips. I love the PCBs. I love all the transistors. I just love learning about them. I love talking about these things. You see a different version of me, Robert, when I talk about hardware, right?
Yeah.
All the other stuff I kind of like, but hardware is what gets me excited, right? And one thing I'm going to point out, I really want all this hardware to disappear. I really do. Because if these things disappear, not only are we consuming less power, our electric grid is not going to be overburdened. We probably can do a whole lot better just by having batteries rather than electric grid that is always, you got to hear the thunder right behind me right now. I could be out of power anytime I'm not expecting it to be, right? So the world that I'm envisioning for 2030, whatever the case is, I really want this hardware to disappear. So that way our power consumption goes down, and we're using those electric grid power, we can do something else. That's something that we probably are not looking at right now because we're saying we don't have that much power in our electric grid. And to top it all off, the data centers are really consuming way too much data right now. I mean, way too much electric grid power right now. So how do we battle with that two things? It's not about a luxury of me saying, let the hardwares disappear. I'm talking about this is a battle of needs, the goods that we need, not necessarily a luxury. So
right.
let me calm down and take my excitement about the NPUs and hardwares and all this jazz we're about to talk
So I was listening to the CEO of NVIDIA.
Yeah.
And he was talking about this new Blackwell chip, right?
Yeah.
And the computational power of this chip. He said something that kind of intrigued me. He said it essentially makes it free. It makes this chip free.
Right.
That's a big thing to wrap your head around. What does that mean? Like, how is it free? Well, it does 40 billion?
Trillion.
40 trillion calculations per second or something like that. It's an insane number of calculations that this chip does.
Well,
so its computational power,
myself.
its computational power is so much more than the old technology, which means that chip will replace hundreds of other chips that are currently being used within a data service center. And so whenever you think of a data service center, well, they have to have electricity usage, they have to have support systems and engineers and people running these facilities. So this chip you'll be able to do so much more with less power and less engineering, less support systems. And that's kind of what he means by saying it'll be free. And all of a sudden, the U.S. government is selling. I don't know if you saw that the U.S. government is actually selling their supercomputer that they have. So it's because this chip makes it so much better that it's for them to even keep what they have running right now. They realize the cost efficiency of having this new chip. But the question is what comes out in the next 6 months? Is it even better than this? Will they have to replace that chip in the next 6 months? There's a lot of questions behind that, right?
I got something wrong. I got the 40 trillion number mixed up with the NPU that Microsoft discussed. Well, this one came out probably around February. That's when they said it back in February, right?
Right.
And March. And then this few weeks ago, this last week, Microsoft talked about the Copilot Plus PC, which is AI that is built into your operating system, AI that is your laptop, right? Not necessarily something that you have to plug in with the internet Wi-Fi. It's literally in your laptop without a Wi-Fi, without internet, right?
That's
I got that number wrong. What I did look up right now, it says 140 billion transistors, the largest chip physically possible. 104 billion transistors.
Blackwell, right?
4 MP process, 10 TBs, terabyte NVIDIA high bandwidth interface, right?
Right.
So you got lots of good numbers here. I'm always saying this over and over to everybody I talk to, be it in a group, be it in an individual level, is that I used to think I know what's going to happen by Thanksgiving. Like I'll have some turkey and I'll have some good meals, right?
Yeah.
I'm thinking every year that goes on, it's like I don't even know what's going to happen next month, right? Used to be able to project out that Thanksgiving days, you'll have Thanksgiving meal, right? Now that you're like, I have no idea what I'm going to do tomorrow because somebody else is going to come with some other hardware. And this is why it's so difficult to fathom. And I'll tell you what somebody who doesn't pay attention to software and hardware have to understand is that there used to be a time where software was just software. It was just sitting there with whatever hardware you have. Everybody has to work with the hardware that's there.
Yeah.
Now what's happening under the surface, that things that we didn't really look into beyond the software, is that hardware is what we needed in order to run that software.
Yeah.
The software, the way it changes, we were able to keep up with it somewhat because it's the surface that's always changing, and we can tell something has changed since yesterday because the update came through. But when the hardware changes, you really are not looking into the hardware and say like, okay, how's the hardware changing? But the pace of hardware changes that's happening in just last 3 or 4 years since that whole TSMC debacle and COVID, where TSMC has shut down semiconductor chips production, do all these, and people were scared, like couldn't manufacture cars, couldn't manufacture a toaster oven, couldn't get their hands on chips. Now you have these chips coming out with this level of sophistication. okay, let's not call it sophistication. It's just processing power that we have not seen before, right? NPUs are processing like what we've seen on an iPhone, but now those iPhone NPUs are available for everybody else to use, right? What if my toaster oven had a machine learning into it, and it came with an NPU? Possibilities are endless, right? It's not something that we could have thought like, okay, look, software can change all day long, hardware not so much.
No.
But I think one big difference that we're seeing right now is that these hardwares are pushing the boundaries because this is a hardware for AI.
Yeah.
This is the hardware for your large language model. This is the hardware for your personal devices, right?
Definitely.
I don't know where to take this conversation, but I'm holding my breath.
the thought about that, what that really boils down to, Asif, is that we're all going to be replacing our laptops, our iPads, our phones, our computers, because currently your phone and your computer does not have the hardware necessary to be able to use the AI that is going to be coming out in the very near future. And so there's going to be a mass demand, I think, in the near future for lots of chips and lots of hardware to be able to support this. Everybody buying a new computer, a new phone, and a new iPad, because you will want the AI integration into your devices. What we're seeing right now is, you see Samsung saying, "Oh, we have AI in our phone." That's not true AI. That's what we're seeing there is it's a software upgrade where we're able to use some software changes to make it seem a little bit more useful in the AI integration world. But true AI will require hardware. And another thing that I had a good discussion with your friend in Dubai about was security. Well, security also requires, the new security in the future will require hardware. And so that means new chips for security devices, new chips for AI devices, new chips for everything. The chip demand is going to be absolutely incredible in the near future, because everybody's going to be needing a new device that has the hardware encrypted security features and the AI abilities to be able to use this new AI, because people that have the new people don't understand that the new AI will do 10x, 100x what you can currently do. It will watch your every move. It will be able to do things for you without you even having to ask them to be done.
I want to hang on to what you said about Samsung, and I think it requires a display, right?
Yeah.
What does it mean to have AI inside of your hardware device?
Having AI inside your hardware device means integrating specialized components and software that enable the device to perform advanced computational tasks, typically associated with artificial intelligence. Here are key aspects of what this entails.
So I think what this just showed, and what the Samsung is claiming, one part of it is that if you have NPU, you're sort of saying that that's the AI that you have, right? But does this AI have the capability of being off the grid, right? Does it work on the edge, right? So they have, like, look, this is an AI that's sitting inside of a device. This device is not AI. This is just a regular iPhone, right? But for it to behave like an AI and do this processing that much faster, be it through internet or not, it's because of the powerful NPU chips that Apple uses. And then now we're seeing it more and more. Like we talked about that the laptop is going to have NPUs, and all these NPUs are coming out. The ability to process data, and I think where you are starting, and I want to create that broadened scope of the hardware security, is that these individual hardware that has these NPU capabilities that are growing in numbers. So that means you really don't have to be connected to the internet. So when I talk to my Siri, I'm talking to the Siri that's inside of my phone, not necessarily over in California, right? Or wherever the database is. But the thing is, like, look, if this AI in my zip code, in my house, knows all the other AIs in this zip code and each device, what happens to your hardware security?
Yeah.
Right? When you're talking about hacking these days, how are we hacking? Right? We're hacking because you're connected to the internet. But if you're not connected to the internet, but you have information about other people's hardware that is literally inside their house, but you really want to access it because you have a bad intention or some other intention, whatever type of intention you have, you access those, right? So the hardware security part of it is like, it cannot be an afterthought. It really has to be like, you want to do on the edge, you want to show off to people, you want to sell. I bet there will be some companies that will just go out and say, who cares about hardware security? I just want people to buy whatever I'm selling. Then we'll figure it out, right? Shoot first, ask questions later.
Sure.
So I think that's where me and you and my friend in Dubai, we're just well, not from Dubai. He lives all over the world for some reason. Funny guy, but just has the power to live anywhere he wants. So this hardware security component and hardware for AI, I think if you combine these two together and say which comes first, I bet a lot of people will say hardware for AI, like no question mark, right? Hardware for security is me and your concern. They're not going to care because whatever sells is what's going to come out first. If people really care about hardware security, and me and you are able to bring that awareness to the wider audience to say, like, do not buy anything that doesn't have hardware security, I think, of course, they're going to flip it. They're going to say, oh, yeah, hardware security matters, right? Market research said so. So I just want to put that in there because when you say Samsung, I think you caught on to something very good, that this big concepts, they really have to start small. And if they have to start small, not everybody has that patience to say, oh, let me move a little bit at a time. So that way it's sustainable and scalable. I think some companies will do that. And I think that's a long-term winner. So, companies that will just say, like, whatever customer asks for today, I'm giving it to them. Sort of like, Henry Ford said, like, if I asked the customer what they wanted, I would have given them a faster horse, right? Instead of building cars. Faster horse is what the customer wanted back in these days. So with that analogy, I would say, hardware security, start there, build your AI around that, because the idea is to have it on the edge. The idea is to have that AI locally made or locally locally operated. And then going back to the concept of how many other AIs are in my zip code, they will have to have not data centers, but towers to ping against each other. And I'm not literally talking about cell phone towers. I'm talking about the idea that these edge devices will have to have a distributed AI system, which is the next after edge, right? And when the edge AI becomes popular, we're going to have distributed AI. Distributed AI, not same as the blockchain AI. I'm talking about distributed AI as in one that supports your edge devices with their capabilities of staying up to date, keeping up to date. Instead of software patch push update, you can't do that on every Tuesday, right? You can't identify the vulnerability on Tuesday before and patch it 7 days later, right? We can't do that anymore. You really have to continuously have this data evaluated and say, yep, your stuff is still secure. Nothing has been poisoned. Nothing has been sabotaged. Whatever the case is, right? If somebody's trying to steal your data, what has delta, right? What delta happened since last time we spoke? So you have all sorts of topics to discover, but let's just stop right there. I think there's a whole lot to chew on.
Yeah, good point. I don't know if you saw the story where Tesla did the fastest recall in history of any car company in the world. The magazine wrote an article about their inefficient braking systems.
That's right.
And that they had very poor braking within all the Teslas. Well, Tesla in 24 hours uploaded a new software package that increased that decreased the braking distance of the vehicles just through a software upload. It was amazing, to see the how they're able to do that just through a simple software change. And that kind of also makes me think about, Steve, how industry is going to utilize artificial intelligence as well. How are we going to see like semiconductor equipment manufacturers and like these fabs that are building these chips for us? how we're going to see AI implemented into those industries as well. And I think that we're going to start seeing a lot of feedback data coming from equipment that's going to be able to be utilized and analyzed through artificial intelligence, and definitely increase the throughput yield of chips, and we're going to be able to see a lot of change coming in the semiconductor industry as well with artificial intelligence, I think, in the near future.
Yeah, I love your background, by the way. You're just making the point, aren't you? Those whole PPA, the power, area, and performance, right?
Right.
It's the Moore's law, right? PPA. We're kind of hitting that top level right now. We're thinking like, man, where do we go next, right? It's only 15 atoms. How can we shrink that to quantum? I think the discussion here about the hardware is fascinating, right? But really to push the edge of it to quantum is going to be a difficult journey, because it's been a long journey to get those 15 atoms side by side display, atomic level depositions and all this stuff. It took a while. So how do you go to quantum, and how fast is quantum between the last piece of atom that you have and all of a sudden you're catching an electron at the right time, right? Or you manipulate an electron. So how do you go there, right? I want to discuss it from a perspective of somebody who has been wrong before. I've been wrong many times. But my part of being wrong is that I underestimated.
Right.
I underestimated. And I can say that out loud because these things are crazy. Right? Yeah. These hardwares are crazy. Like software-wise, I can envision based on the hardware that I've seen 5 years ago. Hardware that I'm seeing today, I'm like, let me really not claim to be that bold. Or maybe I should, right? So when I talked about earlier, all this device disappearing and your AIs being on the edge, your neighbors having so many AIs, and you having AI agents who are doing your work, what do? You go to Jarvis, right? You become like Jarvis, just another really intelligent system, Jarvis, Jarvis from Iron Man. I don't think I'm really overstretching that, because if you really think about it, why would you do like caveman style keyboarding when you can do voice, right?
Sure.
And
Absolutely.
based on what you're saying is that embedded systems, right? An embedded system that requires a on-spot decision making, and it doesn't have the hardware to capture that decision-making capability. You don't have it because you bought a system 5 years ago. You don't want to replace it for another 25 years. But somebody who's going to buy a new device that's going to not require any sort of breakdown, we talked about predictive analytics of how long this machine will last and how to repair this machine before. So the embedded system, what do they do really? Like they're listening for clicks, right? And they're saying, if I hear a click any different than the one that I heard last 100,000 times, something just went wrong.
Yeah.
Go at it. Fix it right now before the machine really gets damaged.
Right.
An embedded system doesn't have a display system and all that. It's an IoT device that's literally giving alerts on every single machine. You can do this system of predictive analytics in many ways, but I'm just using that particular use case and using my imagination to say, like, what does it take to fix that machine? What's the logistics behind that? Does a technician come out and do it? Is it a robot from Tesla, a robot from NVIDIA that comes out and just screws it up a little bit more so that with a belt line is properly working? Do we even have belt line anymore, right? So do you see what I'm getting at? Like, I'm thinking out loud here, but I really want the hardwares to shrink to a point that it does more than what it does today. And it does it far more effectively. And this manufacturing shop floor where the Teslas are built, they're already doing all these things. Because they're not trying to keep up with Ford from 100 years ago. They're trying to keep up with Tesla in the future. Right? So I really want to expand it more. But the thing is, like, you really got to start small and you got to start developing those use cases in-house. And I think one of the things about hardware with AI, the capability that you get is how do you control your data? How do you keep your privacy? And how do you keep it safeguarded for little amount of power? I guess, without compromising the performance, and the area that is not necessarily a big deal, like you have to buy a whole data center to keep your data private.
Right.
So hardware AI, I think we really have to think about it in a different approach, because when I say hardware AI, people think like, oh, the hardware that I'll buy from Best Buy and, or put into my enterprise business, right?
Right.
I'm talking about you develop your own hardware, as in your own chips.
Yeah.
So you see I'm pushing myself here, because now we're used to custom TSMC developed Taiwanese semiconductor chips that will be packaged and given to me for whatever data use case I have.
Yeah.
Now I'm talking about, well, I have this data use case. I want hardware AI for that specific use case.
Yeah.
Nobody else in the world has that.
Yeah. A good friend of mine has
not much, because everybody else has their own tailored semiconductor chips.
But are you familiar with FPGA?
Field programmable, yep. Love FPGAs. I love
Like this is crazy. Like, this is a hardware that is conformed by software, right? So launch a chip into space, an FPGA chip into space, and you're physically changing hardware through a software upload.
Well, that's why military loves it, right? You can burn it so quickly.
Yeah,
it's destroyed.
And, but also think about that in the usage, the usage of IoT. And we're no longer going to have to. The goal is for simple devices, IoT devices, that you could make the IoT device. You don't have to have a chip designed and manufactured just for your device. Now you can stick a field programmable chip in there, and it'll for specific devices, for specific usage. And you'll be able to literally just program that to conform to the IoT device that you're using. So that'll be really neat. That'll be really neat.
I love nerding out with you, man. I think we talk for like hours when we talk. But I want to give a glimpse into what we talk about for hours and 30 minutes of roundtable discussion. So I've been doing this roundtable discussion as many times as possible, but trying to do it every week. We started talking about just the finance side of things. We talked about like cost of large language model. How do you sustain the financial justification behind it?
Yeah.
Because you can start, but you can't quit. But when you start, you really got to understand you don't dump $1 million into it. You dump a few dollars into it and work your way up. And that's literally the possibility today, because what we have learned with software, website development, cloud, and cybersecurity is that you really have to put money up front, right? Or with AI, you do it differently. You learned your lessons, because putting money up front didn't really work out that well for cybersecurity or software programming. So we really have to think about it differently. And it is the reality that you really have to start small amount, discrepant. The amount of money that you spend, don't just go all out, right? Because you really have to sustain yourself. This is like raising a baby. First 9 months, you have a great deal of pain, but what you don't realize is once it's out there walking, crawling, you have a whole nother set of pains, right? And you still got to sustain yourself. You still got to be able to afford that AI baby, right? Mm-hmm. I'm just nerding out here with you, man. But the thing is, like, I think the core message here is that if you don't know, I'm sharing some information with you right now. I don't know where you will start. I don't know where you are in your journey. If you're listening to this roundtable discussion, hopefully you listen to it on a weekly basis. But if this is your first time, check out the other ones about finance, about the MLOps, the life cycle of a AI machine learning cycles and how that works for your business process. This is episode 10. I want to do hundreds of these because I love talking about these topics and see who will be interested in what topic exactly. So my friend, really enjoy all your inputs in semiconductor chips, because that's where my passion is. But AI machine learning and semiconductor chips is like, peanut butter and jelly. Can't have it without jelly.
That's good. Yeah, definitely. Good talking to you, Steve. And we'll look forward to more chats with you in the future.
Absolutely. Looking forward to it. Thanks so much for joining. See you guys next week.
Cheers. Bye.
Cheers. Bye.